Hey everyone, I'm Hiro. Welcome back to the CISA exam prep series. We're back in Chapter 3, Section 1, Project Governance and Management. This is the second half. Let me set the scene. Projects go up in flames in 3 common ways. First, the estimate was based on gut feeling, so the cost overrun goes unnoticed until it's too late. Second, changes pile up verbally, one small request after another, until the scope has ballooned, and the budget and deadline are blown. Third, the project manager keeps reporting, everything's fine, and nobody actually checks the numbers until the delay is impossible to hide. In this video, we cover the management tools that stop all 3 problems: WBS, FPA, Gantt charts, the critical path, change management, and EVA. Let's dig in. The foundation of planning, WBS. First, the work breakdown structure, or WBS. Before you can estimate anything, you need to break the project down into pieces small enough to actually plan. Take a CRM system development project. At the top level, you split it into requirements definition, design and development, and testing and deployment. Then you break each of those down further. Requirements definition splits into current state analysis. 3 days, and writing the requirements document, 5 days. Design and development splits into basic design. 7 days, and implementation, 20 days. Testing and deployment splits into testing, 10 days, and release, 3 days. That smallest piece, the one with an owner and a number of days attached, is called a work package. Why go through all this? Because until you break work down to that level, you can't assign an owner. You can't estimate the duration. And you can't build a real cost estimate. As an auditor, you're checking 2 things. Does the WBS cover all the work, broken down to the smallest unit? And does that breakdown actually support the estimate, or is it just decoration? Measuring size objectively, FPA. Once you know the work packages, you still need to size the software itself. That's where function point analysis, or FPA, comes in. Instead of counting lines of code, which depends entirely on the programming language and the individual developer, FPA counts the number of functions and their complexity. Things like external inputs, external outputs, inquiries, and files, each weighted by how complex they are. Multiply the count by the weight, and you get a function point total for each category. Add them up, and you have an objective size measurement, one that any 2 people can recalculate and agree on. Why does this matter for an audit? Because it removes the estimate from any one engineer's gut feeling. As an auditor, ask whether the size estimate is based on someone's experience and intuition, or on an objective method like FPA. And whether that calculation is actually documented somewhere you can check. Schedule management, Gantt charts. Now we move from sizing the work to scheduling it. The most basic tool here is the Gantt chart. It lays out every task as a horizontal bar along a timeline. So you can see the start date, the end date, and the duration of each task at a glance. You can also see which tasks depend on which, since dependent tasks line up one after another. For a project manager, it's the day-to-day reference for where things stand. For an auditor, it's where you check whether the plan matches what's actually happening. Are tasks starting and finishing when the chart says they should? And do the dependencies drawn on the chart actually reflect reality? The longest path with 0 slack, critical path. Gantt charts are great for simple projects. But once you have dozens of interdependent tasks, you need something more rigorous. That's PERT and CPM. PERT maps every task and its dependencies as a network diagram. Each task gets an expected duration, calculated from an optimistic estimate, a most likely estimate, and a pessimistic estimate. That network becomes the map for the whole project. CPM then uses that map to find the critical path, the single longest chain of dependent tasks from start to finish. This is the path with 0 slack. Every other path has some float. some room to slip a little without affecting the final deadline. The critical path has none. Here's why this matters so much. If any task on the critical path slips by even 1 day, the entire project's completion date slips by that same day. There's no cushion. So as an auditor, you check whether the critical path has actually been identified, whether it's being actively monitored, and whether there's a clear process for reporting and responding to any delay on it. Preventing scope creep, the 4-step change management process. Even with a perfect plan, requirements change. The question is whether those changes go through a formal process, or just get added on verbally. CISA wants the formal version, and it has 4 steps. Step 1, someone submits a request for change, an RFC, in writing. Step 2, the project manager analyzes the impact on cost, schedule, and scope. Step 3, the Change Control Board, or CCB, reviews that analysis and decides whether the business value justifies approving it. Step 4, if it's approved, the plan gets formally updated to reflect the change. Skip this process, and you get scope creep. Someone says, "Can we just add this one thing, and then another thing, and then another, all verbally, all without going back through the steps?" None of them looks dangerous alone. But add them all up, and the budget and the schedule have quietly ballooned without anyone officially deciding that trade-off was worth it. The only real defense is enforcing the formal process every single time. No exceptions for, it's just a small change. EVA, questioning, all is well, with numbers. Last tool. How do you know if a project is actually on track? Instead of just hearing the project manager say, "We're fine." Earned value analysis. EVA replaces that subjective report with 3 hard numbers. Planned value, PV, is the budget for the work that was supposed to be done by this point in time. Earned value, EV, is the budget for the work that's actually been completed. Actual cost, AC, is what was actually spent to complete that work. Compare EV to PV, and you get your schedule story. If EV is higher than PV, you've completed more value than planned, so you're ahead of schedule. If EV is lower than PV, you're behind. Compare EV to AC, and you get your cost story. If EV is higher than AC, you completed more value than you spent, so you're under budget. If EV is lower than AC, you're over budget. Here's the point. A project manager can say, "Everything's on track," while EV is actually lower than both PV and AC, meaning the project is simultaneously behind schedule and over budget. EVA catches that immediately, because it's just math. No opinion involved. Let's wrap up. WBS breaks work down into the smallest units. Work packages, so owner, duration, and cost all become explicit. FPA measures size objectively as function count times complexity, taking gut feel estimates out of the picture. Gantt charts visualize each task's duration, and dependencies and PERT and CPM build on that to identify the critical path. Changes follow 4 steps: RFC, impact analysis, CCB approval, and plan update. Verbal changes are exactly what causes scope creep. And EVA gives you an objective read on both schedule variance, EV versus PV, and cost variance, EV versus AC, using real numbers instead of a status report. Alright, that's it for the second half of section 1. Thanks for watching, and I'll catch you in the next one.